This section is reactions involving gases, and here we get stoichiometry again. So when we have reactions where the reactants or products are gases, then we'll specify the quantity in terms of a volume at a specific temperature and pressure. And so the ideal gas law is very useful in these situations because for stoichiometry we need to know the moles of gas, or we're finding the moles of gas and we want to find the volume. And so we'll use these two rearrangements of the ideal gas law. When gases are at STP, and only when gases are at STP, you can use 1 mole is equal to 22.4 liters. On a test, this will make things much shorter, right? Much faster. So anytime you see STP, you should think, oh, I could probably use 22.4, right? But remember, it's only for gases and it's only at STP. Sometimes we'll have partial pressures because we end up with a mixture of gases, like when we collect a gas over water. But the idea here, so this is our original scheme or path or chant for stoichiometry. Grams to moles to grams, right? That's where you start. Any stoichiometry. You got a chemical reaction in quantities, grams to moles to grams. So if one of your reactants is a gas, then you're going to be given the pressure, volume, and temperature. So instead of G, you're going to have PV and T to moles. And then the ending could be grams. It could be a solution, could be find the molarity, right? Or it could be another gas, and there, again, you could have the pressure, volume, and temperature of a gas. Well, actually, that's not quite right. Well, I suppose it is. Never mind. What you're finding here is the volume. And what you're starting with over here is the volume. And the temperature and the pressure are necessary to calculate the moles from the volume. So here you're using this to calculate moles, and over here you're using the moles to calculate that. Anybody have any questions? So here's an example. The following reaction, 4.58 liters of oxygen was formed at pressure equals 745 millimeters mercury and T equals 308 Kelvin. How many grams of Ag2O decomposed? So we're going to go through and identify the numbers that are given and identify what we're trying to find. And then I'm going to label, or I'm going to put that information under the balanced chemical equation. So they're giving us information about the volume of oxygen gas and the pressure of the oxygen gas. And they also give us the temperature of the oxygen gas, 308 Kelvin. And then the question is, how many grams of Ag2O? Remember, with stoichiometry, you can start with a product, go to a reactant. You can go from one reactant to another reactant. You can take any two pieces, reactants or products, out of that chemical equation and do a calculation from one to the other. So now let's think about grams to moles to grams and how we're going to alter that. Are we given information about the mass of a reactant or product? No, we're given the volume, the pressure, and the temperature of a gas.